Hello, pre-calc. Today's video is going to be on Chapter 8, Section 4, Simplifying Trig Expressions. I believe I started this in class, but I don't remember if I finished it or whatnot. But nevertheless, if I did finish it, I think it'd be good to go over it again. I think it might have been a little hastily done, the notes. So I'm going to take it from the top. Chapter 8, Section 4, Simplifying Trig Expressions. I think I renamed that because we're simplifying expressions. I forget what it said, but I just felt like Simplifying Trig Expressions was a better title for this section. That's probably different from what the textbook says. But let's go over some stuff here. So, remember, tangent of theta is equal to sine of theta over cosine of theta. Cosecant theta is equal to 1 over sine of theta. Reciprocals. Secant theta is equal to 1 over cosine theta. Cotangent theta has two things that it can be equal to depending on what you might require of it. So cotangent's a little more unique. In terms of sine and cosine, cotangent is cosine over sine. In terms of tangent, said that wrong. Cotangent, in terms of cosine, sine and cosine, is cosine over sine. Cotangent, in terms of tangent, is 1 over tangent, because it's the reciprocal of tangent. So, since 1 over tangent is reciprocal, notice that sine over cosine's reciprocal is cosine over sine. Cotangent is the reciprocal of tangent. Okay, so all of these are also could be reversed, but that probably isn't necessary. But what I mean by that is sine is equal to 1 over cosecant. Then cosine would be 1 over secant. Tangent would be 1 over cotangent. Those aren't usually going to be needed that way, but these are the ways that you're going to normally need to change these into either sine and cosine, or sometimes into tangent. Okay. So Pythagorean relationships. Now we went over this in class also, but here it is again. Sine squared plus cosine squared equals 1. I don't have the work written out here, but remember, if this is true, then you can add and subtract things from both sides. So, for instance, if I subtract cosine from both sides, 1 minus cosine is also equal to sine. Or sorry, 1 minus cosine squared is equal to sine squared. You're going to want to keep that in mind. But if sine squared plus cosine squared is equal to 1, then you can divide everything here by cosine. If I divide everything by cosine, I will have tangent, because sine over cosine is tangent. Cosine over cosine squared would be 1, and 1 over cosine squared would be secant squared. So we also have this trig Pythagorean relationship of tangent squared plus 1 equals secant squared. Also, if you divide everything by sine squared, then you'd have 1 cosine over sine would be cotangent, and 1 over sine is cosecant. So whether or not you understand that these are true, just know that these are true. So sine squared plus cosine squared equals 1. Very important. Okay. So with all this, these up here, this here, we're going to simplify trig expressions. We will be given a trig expression. For instance, example 1, sine theta times cotangent theta. And our goal is to write this as one trig function, if possible. Or as few trig functions as possible. That is our goal. Often, and so I rewrote these notes handwritten instead of typed. I feel like, I don't know, I could be wrong. I feel like handwritten might be a little bit easier to follow than typed. But here we go. So one step that will be, if you know of nothing else to do, one thing you could always do is change everything in terms of sine and cosine. And sine of theta times cotangent of theta would be equal to sine of theta times cotangent is sine over cosine, cosine over sine. Sorry. So we can rewrite cotangent as cosine over sine, and you'll notice that the signs then cancel out. There's a sign up here, and there's a sign in the denominator. So this would be the same as sine over 1. Sine would cancel out. The 1 in the top will cancel out with the 1 in the bottom, leaving simply cosine. So we brought it down to just one trig function that is simplified. How cool. Example 2. Cosecant squared of x is times 1 minus cosine squared of x. All right, so cosecant squared of x times 1 minus cosine squared of x. Well, 1 minus cosine squared of x will go to sine squared. And that's because, I gotta just show this all here because my thought bubble over here is prevalent is important to how I found this here, 1 minus cosecant squared, how I changed that to sine squared. Well, since sine squared plus cosine squared is equal to 1, as we had mentioned, you can subtract cosine squared from both sides, and sine squared is equal to 1 minus cosine squared. Well, so that means I can replace the 1 minus cosine squared with the sine squared. How cool is that? Cosecant squared, and so now I'm at the point where if I have nothing else to do, change everything to sine and cosine. So I have a cosecant squared, and I'm going to change that to 1 over sine. But since it's squared, it has to be 1 over sine squared. Okay? So there was 2 of them. Well, you're just changing them both. Well, now I have a sine squared in the bottom, and I have a sine squared in the numerator. They cancel out, and my answer is 1. Well, if you get down to 1, there's no way to question whether or not that is simplified. It has to be. Yeah, it's very, very simplified. Okay, so let's say you might not have realized that 1 minus cosine squared goes to sine squared. Maybe that's not obvious or whatever. There's alternate methods for most of these, and there's a lot of different ways to solve these. So you certainly don't need to solve these the way I have, and it kind of makes it tricky when trying to show these problems because of how many different ways they can be done. There's just a lot of different methods for a lot of these simplifying problems. Ultimately, they should all go to the same answer, but there's a lot of different paths to get there. So never let it be said there's no creativity in math. All right, so another way you can do this is you can distribute the cosecant squared into the parentheses. Okay, this will be a longer method, but it will work, and there's nothing wrong with it. So I'm taking cosecant squared and I'm multiplying it by 1, then minus cosecant squared, and I'm multiplying it by cosine squared. Okay, well, times 1, that goes away, no problem. And then at this point, I'm looking at this, and remember, if there's nothing else that you can think to do, change everything to terms of sine and cosine. So I'm going to take those cosecant squares, and I'm going to change them to 1 over sine squared. Okay, so now I have 1 over sine squared minus 1 over sine squared times cosine squared. Okay, that cosine squared can go in the numerator. Nothing really cancels out at this point. But what you can do at this point is, I have a common denominator. So their subtraction is very important. If there's a subtraction, the only way to combine two things that are subtracted, or added, I should say that, is to have a common denominator. And that's going to be really important for these problems, actually. Not all of them, obviously, but some that we do in the future, you will need to find common denominators. So I have a common denominator of sine squared. And remember, when you're adding common denominators, you add the numerator, and you just, whatever the common denominator is, you just use that. Okay, so I'm taking the numerator, and in this case, I'm subtracting, add or subtract, 1 minus cosine squared over sine squared. Well, you'll notice that it doesn't help us get rid of the 1 minus cosine squared, so we still need to know that 1 minus cosine squared goes to sine squared. And if you don't realize that, you're going to get stuck at a different spot here than you did up here. So it's very important to know sine squared plus cosine squared is equal to 1. But if you do figure that out, and you know that, and you're working through this, and you just happen to work through it this way, you'll get to this point, and the 1 minus cosine squared will go to sine squared, and we have sine squared over sine squared, which is 1. So both methods work and give you 1. Hopefully this is making sense. Of course, send me any questions if you have any. Tangent times cotangent plus tangent. Now, for this one, there's no squared in this. Like, there's not unlike the thing about the Pythagorean trig identities is that they have squared, so that's sine squared and a cosine squared. So if you don't have that, you can't use those. Right now we don't have anything squared. Okay, so I'm going to start by distributing the tangent into both of these. And that will give me, and again, there's multiple ways you can do this. This is not the way you have to do this one. It's the way I chose to do it. But there are many different ways to do these. So I distributed the tangent in, and I have tangent times cotangent plus tangent times tangent. Well, the tangent times tangent becomes tangent squared. So I have tangent times cotangent plus tangent squared. Now, I could change everything to sine and cosine, but if everything's in terms of tangent, and even the cotangent can be changed to tangent, it would be a little less messy to just change this cotangent to 1 over tangent. Remember, cotangent has 2 different things it can be changed to. It can be changed to cosine over sine or 1 over tangent. Well, it's a little bit cleaner, and it's not wrong to change everything to sine and cosine at this point. Like I was saying, it's just the way I chose to do this is to change the cotangent to 1 over tangent, and then I have a tangent over and a 1 over tangent, which cancel out and go to 1. Okay? And now you'll notice that I have 1 plus tangent squared. And I have a squared now. That's whenever you see whenever you see a trig function squared, you might want to think Pythagorean identity. Okay, so if I go back up to these Pythagorean identity problems or relationships, I have a tangent squared plus 1, and I got 1 plus tangent squared. Okay, going back down here. So those are the same thing. So I can change that to secant squared. I have it down to 1 trig function. We can't get rid of the squared, but it's still, we got it down to 1 trig function. Okay, cool. All right, so example 4, another example. Cosine times cotangent plus sine. And in this case, we have sines and cosines, so the cotangent, instead of making it 1 over tangent, I still would have 3 trig functions. It would make more sense to change it to sine and cosine, because then I can get this entire thing into terms of sine and cosine, because I have the cosine, I have the sine. Well, then change this to cosine over sine, and I have everything in terms of sine and cosine. So I have cosine times cosine over sine. That'll be cosine squared over sine. Okay? Plus sine x. Okay? So this is where, what do we do at this point? Well, I was saying if you get stuck, change everything to sine cosine. Everything is in sine cosine, right? So what I want to do at this point is try to add these 2 trig functions together. That's another thing that might be helpful, is that if you get stuck and there's a plus or a minus, try and combine them. The only way to combine 2 numbers is to have a common denominator. 2 numbers, but 2 of anything, not just numbers. These aren't numbers. Is to have a common denominator. So, in order to have a common denominator for this, I need to have this sign, which would be sine over 1. Anything that's not in a fraction is over 1. I need to change this to be something over sine. Well, I can do that by multiplying it by sine over sine. Sine over sine is 1. So I'm not changing anything by multiplying sine x times sine over sine. But I do gain something in that I now can write this as something over sine. And it's going to be sine squared over sine. And I did that because I had a sign over here. I had a sign in the denominator over here. I wanted a sign in the denominator over on this side, so I multiplied this number by this denominator over itself. and that will give me a common denominator of sine. So now I have two things and both of them over sine. Now look at this, sine squared over sine would simplify to sine. So this is the same thing, these are equal. But it's going to give me the ability to combine these two fractions. And cosine, when you add fractions, you have a common denominator, you add the numerator, keep the denominator as is. So cosine squared plus sine squared, it's going to all be over sine. And hopefully by now I've said it enough. Sine plus cosine, sine squared plus cosine squared is equal to 1. Cosine squared plus sine squared is the same thing because addition is commutative. And so we get a 1 in the numerator, a sine in the denominator, but we're not done yet because we can write this as one trig function that's not in a fraction, and that would be cosecant. Fun stuff. As you can see, these just get more complicated and more complicated. Or as I like to say it, more fun and more fun. All right, so here we go. Secant x plus cosecant x all over 1 plus tangent x. Okay, again, I'm looking at this and I'm not seeing any squareds. There's nothing squared yet. Well, just like this up here, nothing was squared. But after we worked with it a little bit, we did get some things that were squared that enable us to use the Pythagorean trig identity. So maybe that's going to happen. Maybe it's not. We'll have to find out. But there's nothing squared. And these are not in terms of sine and cosine. And again, I keep saying this, there's many different ways to do this problem. But I'm going to start by changing everything in terms of sine and cosine. So secant goes to 1 over cosine, cosecant goes to 1 over sine, and tangent goes to sine over cosine. 1 will just stay 1. And I have this mess of a fraction. 1 over cosine plus 1 over sine. All of that in a bigger fraction, which is 1 plus sine over cosine. Now I'm going to look at these and I'm going to try and combine the numerator by finding a common denominator from 1 over cosine and 1 over sine. Well, I can find a numerator, or I can find a common denominator by multiplying each fraction by the other fraction's denominator. So, for instance, 1 over cosine, I can multiply by sine over sine, and 1 over sine I can multiply by cosine over cosine. Okay, again, this is 1, so it cancels out if I wanted to go that way. This is 1, so I'm not changing anything. But what I'll get in the denominator of both is sine times cosine. Well, this side I'm going to get cosine times sine, but that's commutative, so sine times cosine in the denominator of both of these. And in the numerator, I'm going to get sine on this one and cosine on this one. While that is happening, simultaneous to that, okay, crazy stuff going on here, right? I'm going to want to add 1 to sine over cosine. I need a common denominator again. Well, I can multiply 1 by the denominator of this fraction, multiply 1 by cosine over cosine, and I will get cosine over cosine times 1, which will be cosine over cosine, which would simplify to 1. So it makes sense that I'm not changing the number 1 by writing it as cosine over cosine. Okay, so I'm going to condense all these multiplications here and get sine over cosine times sine, which is the same as sine times cosine. On this part right here, I'm going to get cosine over sine cosine. And then I'm going to have cosine over cosine plus sine over cosine. Okay, following this. In the numerator, I can now add these two fractions together. I'm going to have sine plus cosine over sine times cosine. In the denominator, I can now add these two fractions together. I'm going to have cosine plus sine over cosine. Okay? This is coming together now. Division. The process of dividing is the same as multiplying by the reciprocal. So I can take any division, any fraction, and I can change it to the numerator times the reciprocal of the denominator. 3 over 4, the fraction 3/4 is the same as 3 times 1/4. The reciprocal of 4 is 1/4. Okay? So 7 over 10 is the same as 7 times 1/10. All right? So I can rewrite this division as, I have an example here. I can rewrite this division right here. The bigger division, the division that is dividing the fraction in the overall numerator and the overall denominator. I'm going to change that to the numerator, which is sine plus cosine, over sine cosine, times the reciprocal of the denominator. So sine plus cosine is going to go in the denominator, cosine's in the numerator. Okay. I have an example of this. 1/2 of 3/4 is the same as 1/2 times 4/3, which will be 2/3. And if you don't believe that, you can always, with an example like this, you can always put it in your calculator, and you do need to make sure you do parens correctly here. If you mess up the parens, you might not get the correct answer. See, that's 2/3, which is the same as 1/2 times, oh, again with the parens. We don't really need it for the first fraction, but to make it look more clear, let me put it in. Oh. And once again, 2/3. Confirmation. But that's really important, because once you do that, you can kind of see some things that cancel out. The sine plus cosine, they cancel each other out. The cosine plus sine, I changed to sine plus cosine because addition is commutative. It doesn't matter which one you put first. But going back down here, the sine plus cosine cancel each other out. Cosine and cosine cancel each other out. We're left with 1 over sine, which is cosecant. Whew. Fun stuff. And we're not even done yet. Here I thought we were done. Nope. I didn't even remember there was another one. Okay. So, example 6. This is probably the last one. It's got to be the last one. Let me know how low we are on the school bar. Alright, so secant over cosecant minus tangent over cotangent. I'm looking at this. There's nothing squared. I'm thinking we're changing everything to sine and cosine to start. Okay. Secant 1 over cosine minus sine over cosine over sine. Alright, we're going to do the same thing we just did. Multiplying by, or dividing is the same as multiplying by the reciprocal. So I have 1 over cosine, which is the numerator, times the reciprocal of cosine is 1 over cosine. Okay, minus sine over cosine times sine over cosine. This is flipping sine over cosine. Okay, that gives me 1 times 1 in the numerator, cosine times cosine in the denominator. Over here, separated by the minus, sine times sine is sine squared over cosine squared. Conveniently, I have a common denominator already. That's real nice. So I don't have to multiply each of these fractions by something, so I can add them together. 1 minus sine squared over cosine squared. 1 minus sine squared is the same thing as, you guessed it, cosine squared. Pythagorean trig identity. Sine squared plus cosine squared is equal to 1. Well, you can subtract sine squared from both sides. And you get cosine squared. Cosine squared over cosine squared is 1. And now we are done with this practice. Alright, so the bookwork is here. I'll have a PDF of that, or an image of that, I can't remember, for you to be able to do. And I have a work packet that I will also provide in a PDF for you to do. So this is pretty complicated stuff. It's not easy. There's a lot of different ways to do these problems. There's a lot of different paths to take. It's not always easy to see what the next step is. But 2 tips I had given throughout this lesson was change everything to sine and cosine, and also find a common denominator when there's addition or subtraction. Not that that'll always be the perfect way to do things, but not that there is a perfect way to do things, because there's a lot of different paths to take. But hopefully I have enough examples here to help you. And as always, feel free to ask questions. Thank you, and good day.